So today we're going to start looking at trigonometry and specifically starting to look at what are called trigonometric ratios. This kind of way that we look at how the angles and the sides in triangles make those certain ratios within a triangle. And so we're going to start today by looking at what these three main ratios, which are called sine, cosine, and tangent. There are more than these three, but these are the three kind of basic ones that the other things will build off of. When you look at a calculator, your calculator will have buttons for these, and it'll just be abbreviated SIN, but we pronounce it sine, COS, which we say cosine, or TAN, which we pronounce as tangent. And this is what we're going to start looking at today. Now, what I really want you to make sure that the first thing you should put in your notes is you should put this funny word that's up here in your notes. I learned this, and a lot of people, maybe your parents have learned this, by remembering the word SOHCAHTOA. And you see this kind of funny word written up there. The word SOHCAHTOA gives us a way to remember these different ratios. So for example, when we look at sine, we're looking at the sine of a certain angle, and we make this ratio by putting the length of the opposite side over the hypotenuse. And this is where we get that OH that you see in the SO, opposite over hypotenuse. And then cosine, when we look at that, we're going to be looking at the side that's adjacent over the hypotenuse. And again, you'll see the A and H that'll help us remember that ratio. And finally, the tangent is your opposite over the adjacent. And so these different ratios are what we're going to start looking at today in trigonometry. You'll see that I have this triangle here, and I know the sides, their lengths. I also have some angles that are labeled here. So what I'm going to do is, so for example, if I want to find the sine of x, remember that I want to have that opposite over the hypotenuse. I might just write that here so that I remember. Okay, so now what I'm going to do is I'm going to look at x. The side opposite it is 24. And the hypotenuse, remember your hypotenuse is always the one across from that right angle. And so my hypotenuse is 30. So my sine of x is 24 over 30. But I need to simplify that. So this is going to simplify down to, let's see, 4/5. And so this would be my sine of that angle x. So the main thing we're doing here as we're setting up these ratios are looking at what type of ratio am I looking at, what sides do I need to find, and then writing my ratio as simplified as I can write it. Let's look at another example. With this same triangle, what if I wanted to find the cosine of z? Well, I know that cosine is adjacent over hypotenuse. And so I'm going to look over here and start with my angle z. My adjacent side, adjacent is the one right next to it, is 24. And my hypotenuse is 30. Look what happened. It's actually the same ratio, right? We're looking at a different angle, but came up with the same ratio. Let's look at a few more examples. Tangent of x, right, is the opposite over the adjacent. So the opposite of x is 24. And my adjacent side is 18. Remember that when you're looking at adjacent, you want the side that's touching it. There's kind of two sides that are touching this x, but this is always called the hypotenuse, that side that's across from the right angle. So we want the other one. So 24 over 18. So we can simplify this into 4/3, and that's our ratio. Okay, so I'm going to give you a couple more that I want you to find. Okay, here are a couple of new ones, the cosine of x and the tangent of z. I want you to go ahead and pause this video and see if you can write the ratios of these two trigonometric ratios. Okay, let's try together. Hopefully you tried something. So when we look at the cosine, we want to say the opposite, nope, the adjacent, look at that, adjacent over the hypotenuse. So I look at angle x. Adjacent is 18 over the hypotenuse is always that long one across from the right angle, which is 30. I want to make sure that it's simplified, right? So I could cut both of those in half. They can still be simplified more. So here's my final cosine of x. Okay, then I have one here that says the tangent of z. So I know that tangent is the opposite over the adjacent. I'm starting with a z. My opposite side is 18. My adjacent side here is 24. Then just make sure that it's simplified as much as possible. So I noticed that both of these can be divided by 3. So we'll have 6/8, but they can be simplified down more, right? So we'll have 3/4. So make sure that you end up with your most simplified answer. So these are trigonometric ratios. Okay, let's look at one more example. So here you see another triangle. Again, we know all 3 sides. Sometimes when you look at these problems, you might only know 2, and that's okay, but we can only find the ratios with the sides that we know. So here we're given all 3, and we also know the names of these angles. So if I want to find the tangent of B, well, remember either from your notes or from this funny word, we know that tangent has to be the opposite over the adjacent. So when I look at angle B, my opposite side is 27. My adjacent side is 36. I'm going to simplify this. And then when you get to your final answer, just make sure that fraction is as simplified as possible and leave it as a fraction. We don't want to write this as a decimal. As we start working with these trigonometric ratios, you'll see that when it's used as a fraction, we can kind of put it back onto the triangle. We know a lot more of the relationships. So don't be tempted to plug that in and get a decimal. What if I wanted to find the sine of B? Well, I know that sine is opposite over hypotenuse. I'm looking at angle B. So opposite is 27. And the hypotenuse, that leg that's across from our 90 degrees, is 45. I'm going to simplify that as much as possible. Just leave it as that fraction. Okay, so these are trigonometric relationships.